Hello and welcome to this video. This is Chanda, and in this video we will be doing an exercise regarding the nuvoton board. The aim for the exercise is blinking of an LED, the LED which is on board of the nuvoton. Here we are taking the RGB LED, the blinking of RGB LED. The RGB LED, it is nothing but the combination, or you can say the color shade of that LED. The glowing shade of that LED is nothing but the combination of three configuration. We will be seeing the blinking of this LED by a certain code. Here we go. Here I have pre-typed a code. Before telling you about this code, I would like to tell you about the this software in which I am working is. This is the Kale version 4. Uh, how to build up any project, I will just tell you. Go to this project, take a new project. Wherever you want to save it with certain name and say save. It will ask for which IC you will like to use. Here, as we are using nuvoton, I click on nuvoton, and that specifically the which we are using is NUC 140 NEC 3CN. Search for it in this, and here it is. Say okay. Sorry, it's 3N. This is C 3CN. Okay, so say okay. And it will ask for the startup to project folder and add files to project. If you want to say yes, if you're working on a product level, then you can say it yes and all those things. I'll say yes for that. Then take a new file. As you can see at target, you have created a source group. Okay, before that, the file which you have created, save it. As we are working with C, save it with extension .c, save it with some certain name and .c, and save it. It will get saved with the extension .c. And in your source group, you can see there is only startup file. You have to add or attach this .c file to this. So what you have to do, at source, right click and say add existing file, and search for the file name. It's here. Say add and close. As you can see here, your file got attached. And as we are working with nuvoton board, we have to add some other more files, the header files, or you can say the startup files, and all those files we have to attach in our source group. Do the similar way. Right click, manage components, and from here you have to take the components. If the components are not available, say add files. In this file, I will see my few files which I have to attach. In this file, I will search for where you have stored it. See, I will need the system file, so I will say add and close, and system file is here. Say add file. Okay, some any more if you want, you can attach from here. Add, there are 13 header files required for this program. As such, you add all those header files and say add files and close it. In this way, you can create your window, and here now you can type your code. Okay, so here I have typed code for the LED blinking on and off. That is okay. In this, we have to initially assign all the header files whatever we will require. This is for the interfacing of any sensors or anything LCD or all those things. We have to assign all those header files. Coming to the our main function, in that what we used is this is a direct command given. It means that the GPC, the general purpose port C of the name P, and E means for enable. It means enable the port C pin number 12, which it will act like an output, means enabling input and output I'm using it as an output pin. Similar way, this is port A, pin 12, port A 13, port A 14. Enable all those pins and I have assigned it as an output pin. Okay, coming to the code, here a continuous while loop I'm taking, which will generate a continuous loop. And in this what I'm doing, the port pin 12, 13 and 14, first it will blink, means it will not blink, it will it gives the number 1. It means it will create some particular shade of color for that LED glowing. And I'm giving a delay, count delay. I will explain that subroutine of that. Then what I'm doing, after particular delay, that color shade whatever the formed by this combination will get off, means it will show me on off of a particular shade. And then again I'm giving a delay, then again it will get on, again it will get off. And here this in subroutine what I did is, I here took the port C pin 12. What I'm doing, I'm initially making it off for particular duration with a delay of this, then I'm making it on. Means this complete delay means when it is on, it will call after a particular, then it will call a delay. In that delay, this pin 12, it will glow and off. Okay, for this particular delay it will on and off. And then this port A pins combination LED will get off, and again a count is there, means again this subroutine will be called, and again that the port C pin 12 get on and off for a particular delay. This is actually an optional, this on and off of a port C pin 12, it's an optional. You can add or you can't add, or you simply just give a delay by a for loop, it's also okay. This is an optional thing to to have a gap or to see the delay between whether to identify that there is a delay. You can for visualizing you can use this LED onboard LED pin 12. It's an optional, as I said. uh, After this, build up this VI from this build up option, and then rebuild and compile and see the output on the onboard. After creating or after building up a file, then you need to create a hex file to dump it in a tool. For that, go to project, options for target 1, and that select the frequency, which here will take 12 megahertz. Then go to outputs, then say create hex file, say OK, and you will get created your hex file in the folder in which you have stored your this all project. You will see the hex file over there, and you need to dump this hex file in the tool named as nuvoton new micro ICP programming tool 1.21. You need to dump there and say OK and see the output at the onboard nuvoton. After uploading the hex file, you can see the RGB LED of the whitish blue color gets on off, gets blinked. Thank you.